this is what we are going to focus on in this talk. Around APIs, how can we detect authorization vulnerabilities, shift left, and before they are released to production. So it's in CI/CD pipeline. A lot of you might have already done this. A lot of you might already have a lot of experience in this. If that's the case, please share your experiences. Please feel free anytime to suggest if something is, if I'm not covering something, feel free to chime in. Feel free to put your suggestions in. That'll be a lovely thing to do. Just with a show of hands, so that I can understand you better. How many of us are developers over here or are on the software development side? And how many of us are part of AppSec teams? Wow, that's good. And the others, are you part of security but not AppSec or? Okay, got it. Nice. Well, I think I have something for everyone over here. So let's get started. We are going to focus pretty much on authorization testing. It's one of the hardest, in my opinion at least, it's one of the hardest things to automate. The whole part of authorization testing, how do you define your authorization policies, how do you monitor for them, and how do you test that the software development team has implemented the authorization rules correctly. And yeah, my favorite quote, you can, but you may not. If that's the case, there is probably an authorization problem. So let's first define what is an authorization problem. If a user who is a part of the platform, see, if a user can access or modify data without being part of the problem, without being part of the platform, that's a whole different issue altogether. That's probably something like broken authentication. I'm not even a part of the platform, yet I can read or modify a lot of sensitive data. We are not dealing with those kind of issues over here. We are dealing with when you know the user is indeed a part of the platform. So yes, user will have some sort of login credentials, user will have some sort of an authorization token because the user is logged in. Now those users will, on the user interface or through APIs, can have access to a lot of functionalities. They can read a lot of data, they can modify or delete a lot of data. For example, DoorDash or Netflix. I am a part of the Netflix platform. I can log in, I can check my view history, what movies I have watched, my profile details, maybe my payment details as well. I have access to all of them. If one of you also have access to that, that's a problem. And so that's the thing. If I have access to things I should not have access to, that's an authorization problem. What I have over here is a small example from Juice Shop. So one user has posted a review of the platform, of some product over here, saying it's bad apple. If I, as a totally different user, can go ahead and modify this review, that's a broken authorization problem. And that's how you can simply define broken authorization problems. Now, multiple kinds of applications like Netflix or applications like DoorDash, all users, we are all the same, right? We are all like, it's a consumer application, all the consumers are pretty much the same. If it's a business application, then things become a bit more complicated because now you have a member role and you might have an admin role, probably a billing role. Imagine something like Slack. That's a third kind of a problem where we might be all of the same role, like members of the Slack account or a Slack organization, but I have created some private groups that you should not have access to. God help me if you have access to, but yeah, you should not have access to those groups. Yeah, so different kind of applications can bring in different flavors of authorization testing, and I'll try to cover, I think I have 5 flavors covered over here. There could be more. If there are, feel free to suggest. We are happy to discuss those. But yeah, that's what we are going to focus over here. Um, Now the first question, why? Why do we want to do authorization testing? I mean, the CV database is full of authorization problems. If you just query for the word authorization, you will right away get 3,000 records in the whole CV database. Some recent ones, Grafana. If you're a software engineer or like a DevOps or an infra engineer, you must definitely know Grafana. I can save a lot of infrastructure snapshots, health of my systems in Grafana. We use Grafana to monitor our systems. Any user can come and delete a snapshot, and that's a problem without being part of the platform. Actually, part of the platform, but part of a different organization. So that's the thing. A user should be a part of the Grafana ecosystem. Like they should have login credentials, but not to my organization, to a different organization. And even then, they can come and delete my snapshots. That's a big problem. Similarly, Gitlab. Let's say I set up my own project. You are not part of my project, but I can still add you as pull request assignees. I can assign pull requests to you or merge requests to you. Again, a sort of an authorization issue. I should not be able to do it, but I can. And yeah, especially these kind of issues, yeah, you will have some understanding on who did this because the user has to be part of the platform. But yeah, the damage is done. Like if a malicious user gets to know about these things, they can actually have a lot of nasty, devastating effects on your data. One thing is access, but they can actually drop your data. For example, in Grafana, they can actually delete the screenshots. So it's very important that we define our API policies very thoroughly, exhaustively. We kind of test them before they are released to production. Again, it's one job to implement all the policies. It's totally a different job to make sure they're implemented correctly. And that's where we are going to focus a bit. How can we implement and make sure the authorization policies are all correct? I think I was listing a few kinds of authorization testing. So here are some different flavors of how authorization testing can look like. I mean, in your context, one can apply one or the other can apply. The first thing is quite simple. The way we looked it over here, I am a simple user of Juice Shop. Can I edit any other user's review? That's your typical IDOR or BOLA attack, if you must have heard about it. The second is role-based testing. This means I have a user. It's like, imagine like a business app, like a group of users are part of the same account. I don't have admin privileges on the account, but I can still go ahead and execute some of those admin functionalities. It might be the case that I cannot do it through the user interface, but if I just hit the API, it might just work. So that's role-based testing. Resource-based testing is, let's say, for example, Jira or Slack. Jira has projects. I will create, as a manager, I'll create my own Jira project. No other manager can take a look at it. But hey, what if they can? Like if they just call the API, they can, right? It's not there in the user interface, but it's there. If they just call the API, they will just fetch all the data. Plan-based testing. This is interesting. So typically, and especially with a lot of consumer and especially business-facing apps, a lot of the apps have tiers. You have a free plan, you have a business plan, you have an enterprise plan, and so on and so forth. And each plan has more features than the previous one. Now, if let's say an enterprise plan offers unlimited usage or offers unlimited users being a part of your account, you wouldn't want that to happen in a lower plan. Through UI it's blocked, through web interface it's blocked, but it might not be blocked through API access. And that's something that you should definitely test for, because if unchecked, some malicious users can grow their accounts as much as possible. It's going to result into increased infra costs, increased database costs, and so on and so forth. The last one, it's like a very high enterprises thing, but if sometimes sometimes the accounts are provisioned on separate tenants. In this case, we are all part of the same tenant, we are all part of the same juice shop infrastructure. Um, but if you have heard of Jira, if you have heard of Bitbucket, you can have separate tenants for each of these. And again, it should be tested that a user of one tenant should not be able to access or modify data of a different tenant altogether. So yeah, a lot of flavors in which authorization problems can come. Maybe there are more, but yeah, these are at least the business logic ones that we are going to focus on in this talk. Excuse me. So a lot of places where you can solve or test for authorization issues, you can do it as part of your API policies and API planning. If your organization implements an API design phase, that's the best place to start with. It can also happen when developers are implementing the API policies. Again, sometimes API policies are implemented separately from business logic. For example, API policies can go on a gateway, and sometimes API policies are part of the business logic itself. In build process, and that's what we're going to focus on the most, we have to scan, we have to set up automated tests for all possible types of authorization issues that can arise. In pre-prod environments, again through testing, through manual testing or automated testing, we should be able to check if authorization problems are there. Let's get started. API design phase. This is probably, I mean, if you do this really well, it's going to solve, the problem is half solved already. You should have complete visibility into what roles and permissions do you want to allow in your product, what kind of resources your product might have. Resources could be something like an account, a user. If you're talking about Netflix, resources are movies, watch history, payment details, and so on and so forth. Resources, you can imagine, it's like an entity that's saved in the database, right? So whatever you want to save in the database, call that a resource. And then you have access controls. What role can access what functionalities on those resources? Again, if you already have it, that's great. If you don't have it, it's worth investing time over here. Some good principles: always version your APIs and API releases. It's gonna ease your process a lot if your APIs follow some sort of a pattern. For example, API v1 user details /123, right? So or API v1 movies /movie ID, right? So each API now represents what's the resource type: movie, user, comment, payment, etc., etc. And the next entity is like the ID itself. Yeah, API implementation. Again, this means two things: actually implementing the business logic for that API, and the other part is implementing roles and authorization checks on that API. In my opinion, you should keep them separate. API access should be defined or like as a policy in some sort of a code. So if you can afford, if your teams can afford it, do have API policies. They can be in any language, they can be in any format, but yeah, API policies should be separate, structurally separate from your API implementations at least. And if you can have all the policies in one place, that's great. Then that's all that you have to do to check if the policies are defined correctly. Excuse me. Now, in order to make sure developers do that, or developers have to do that, is to have some tools in place. You can have some source code analysis tools. You can use their default rule set. Some source code analysis tools allow you to define custom rules. So if you want to do that, go ahead. But yeah, it's very, very important that you check for each API that's defined, is there an equivalent policy defined or not? Is that API documented or not? If not, raise an alert. And again, going a step further, raise an alert before the developers can commit that new API, or at least before the developers can merge it to the main branch. All right, so once merged, typically there's a staging testing phase involved, and this is where things become interesting. This is where things become hard to implement. Now, we are going to assume here for each scenario, some sort of an application like Jira or Slack or Netflix, and then we'll see how we can implement that kind of testing in place. So for IDOR and BOLA testing, we basically should have a list of all the resources. Again, in the API design phase, we already created that. But if you have a list of resources that are present in your application, like for example in Netflix, movie is a resource, TV show is a resource, payment details are a resource, user data, profile settings, they're all resources. Have a list of all the resources, and all you got to do is try, like, set up two accounts, a victim and an attacker account somewhere in your staging environment. Yeah, this is where if you have someone with development expertise in your team, they can help you. You should be able to programmatically create resources in the victim account, and from the attacker account try and fetch or modify those resources. For example, if we take that, if we go back to the juice shop example, comment is a resource. Any user can comment on any given product in juice shop. Again, there should be an automated test which creates a comment on the juice shop platform in your staging environment, and there's an attacker who tries to modify that comment. If the attacker can do that, that's a vulnerability. And if you have set up this test automatically in your CI/CD on your staging environment, you will catch it before the API goes to production. Now, in deleting a comment might not seem like a big deal, but imagine if this was payment data, or if this was your social media data, or if this was your I don't know, academic data, insurance data. A lot of these places, this can become a very nasty problem. It can also be your infrastructure data, your infrastructure credentials, your secret keys. If anyone can delete your secret keys, that's again going to be a big problem. It's going to cause you downtime. So yeah, depending on what kind of resource it is, how critical it is, the severity might change, but the way to automate this testing remains pretty much the same. You just have to list all the resources. You have to define a victim which can create all those resources in their account, and an attacker who tries to delete or fetch those resources. And this point is one of the main things, and this is where we see that a lot of AppSec teams can face hardships. If you want to set it up like in an automated kind of an environment where you can run this test daily, or you can run this test before every release in your CI/CD pipeline, in your DevSecOps pipeline, you have to be able to automate the auth token, because a victim, how it's going to create the resources, you're going to programmatically create the resources, right? To create resources, you need an auth token. And if your auth token usually comes at the end of a login flow. If your login flow is simple, like username, password, can be automated. But if your login flow involves SSO or OTPs or email magic links, that's going to be hard to automate. So yeah, I leave it to you. Typically, one good thing is in your staging environments, relax the login flow, remove captchas, have like a constant OTP so that you can have automation in place, or use like a username, password login in your staging environment so that you can automate the auth token generation. Once you can automatically create an auth token, then creating the resources becomes a lot more easier. I would like to take a pause over here. Any questions, any comments, suggestions? All right. By the way, QA teams especially do deal with similar kind of stuff. I mean, instead of checking security problems, they check functionality problems, but they might have a lot of these processes already set up in their automation pipelines. Role-based testing. So let's take an example of Jira, if you must have used, or Slack or Teams. There are members who can come and view a project or come and view a channel. Then there are admins who can invite members or remove members. There is a billing role. They can't do much, but they can check all the invoices, they can modify the payment information, they can sometimes terminate the contract as well, upgrade a plan, downgrade a plan, they can do all sorts of things. Or an HR admin software. I as an employee can only view my data, my leaves I've taken so far, my pending leaves, my performance scores, my manager's review, and so on and so forth. HR admin can take a look, can see everyone's data. My manager can take a look at my team's data only and nowhere else. So a lot of like roles in that application, and this is where things become interesting, because now, well, what you have to do is define each role, define all the functionalities. For example, the first functionality over here is to just simply get account details. The second functionality is to modify account details. Now modification only admin can do, a member and a billing can't do, shouldn't be able to do any modifications to account details. Yeah, sure, all three can view their account data, but only admins can modify the account data. Now if that's the case, we basically have to check in our staging environments, all these cross marks, we have to make sure they're actually crossed. I mean, it's one thing that someone has documented this for you, but in reality it might happen that a member can also go ahead and change account details. They can't do it through UI, but they can just call that API and it might just work. So as security teams, we have to make sure this can't happen, and again, it's again an order of magnitude difficult than the previous IDOT testing, because there we had like two simple users. Here we have a complex combination of roles and roles and APIs, and you create this table and so on. The thing is, roles are finite, like you can have 3, 4, if it's a big app, maybe 10 roles. 10 is a lot, but at least a finite number. Excuse me. What you have to do in your staging environment is have one account which has all of these roles. So each user, for each role there should be a user that's configured. You should be able to create that user's auth token automatically, as we discussed earlier, and all you got to do is just keep testing the APIs which are marked as cross. So for each cell that marked as cross, keep checking if the API returns a 403 or a not authorized error. So I would just go ahead in my staging pipeline, I'll say for each role, for member, fire this patch API and see if it works. If it works, it's a problem. You should fail the CI/CD pipeline. You should ask the developers to go back and fix it. Similarly for billing, just check the billing role user should not be able to access that API. That's role-based testing. Now the problem becomes even more harder if you don't have defined roles, but you have a lot of defined permissions. So permissions can look like account read, account write, user add, user remove, user invite. You must have seen these kind of things when you're sharing documents or spreadsheets or some Google presentations with other people. It asks you, do you want to share this with a user who can just view, who can view and comment, or who can edit as well? They should be a part of the organization or not, and a lot of such things. They're all, these are not roles, but these are permissions. And roles are small in number, like 5, 6, maybe 10. Permissions can be 50 in number or even 100. Depends on the complexity of the application, but if your application offers permission-based configurations, it's a lot harder. Um, the best way I have seen that someone can test for uh, all these sorts of like 100 permissions is, first of all, make sure your API policy document is very well in place. It's going to become handy a lot. This is how an API policy document should look like. So for each API policy, what all APIs, I mean for each kind of a permission, what all APIs are allowed for that permission. Um, you start with the user which has no permissions at all, okay, and let that user fire all the APIs that are marked as cross. If anything returns a positive answer like 200 okay or 201, it's again a vulnerability. Then you incrementally add the permissions one by one. Then I'll incrementally add account read and make sure for the rest of the table I still can't access any APIs. I hope I'm making sense. But yeah, the idea is you start with least privileged user, you incrementally add the permissions one by one, and you check if all those increments, they don't disturb your table. Your table data, all the crosses should still be crosses. Any questions, guys, so far? Yeah, this permission-based testing is probably the hardest one to configure. You can have in an application, sort of medium-sized application, you can have like 500 to 1000 APIs, and you can have 50 permissions. So it's going to be a huge table. I mean, for example, I have put it a very small table, but yeah, in reality, it's going to be a huge table. It's not hard to automate though. Like once you get into it, it should be possible to automate as long as you have that API policy table defined for you. The next one is plan-based testing. This one requires a different kind of an API access table, and this is usually a part of documentation. Like every product has a documentation. In the documentation, they do mention what kind of plans are available to all the users, and in each plan in detail, what all features are a part of that plan. So this is all very well documented. All you got to do is have accounts for each kind of a plan. So I should have a business plan account, I should have an enterprise plan account in my staging environment, maybe a free plan account. So and for each account we have to check if APIs, yeah, that's the thing. Audit logs or unlimited usage, I'm putting like one cross over here, but that could be a combination of APIs like audit logs, fetch audit logs, delete audit logs, filter or search audit logs, multiple APIs associated for each feature. So yeah, you get this documentation for each feature. You should know what all APIs are associated with that feature, and yeah, get your automation running. Like for each account, for each feature, wherever there's a cross, try and access those APIs. If any of the cross APIs work, again, it's a vulnerability. Depending on what feature it is, like audit logs, it's okay if a free plan user can see their audit logs, but it's not okay if a free plan user can use unlimited data. Like imagine all of us can use unlimited space on Gmail, or all of us can use unlimited space on Dropbox. It's going to be a nasty problem for those organizations. I think that was the main part of it. The last thing is production. Although we started with shift left, but yeah, in real time, it's worth setting up some sort of monitoring that how much data is being accessed by how many users. Is there someone who is trying to, for example, just brute force through the IDs or brute force through OTPs, trying to exploit any sort of authorization attack? It'll be good if you can have like an alert system in place. Then at least, well, you have made sure no vulnerability is going to production. If at all something makes through, your monitoring probably can alert you at the right time. Again, very hard to automate, very hard to get it right. But yeah, if you can set up, let's say, some custom rules based on the application, that's good. Anytime you detect a successful broken authorization attack in production, yeah, it should definitely go back to your development team. It should definitely go back, and you should get it fixed in your CI pipeline. One interesting combination I've seen a lot of people I've spoken to is they set up this kind of monitoring in their staging environments as well. So there is probably a dash scanner or an API scanner just trying to put as many malicious requests as possible, and if something successful exploitation is detected by that runtime monitoring tool, then you kind of catch it in the staging phase itself, and you can go back to the developer and ask them to fix it. I think that's what I had for you guys today. A bit about Acto. We are an open source API security platform. We have our own test library meant for APIs. All homegrowns. Here are some GitHub handles or Twitter handles that you can use. Our motto is secure every API before they are deployed. Yeah, I'm open for questions now. Yeah.
I'm just curious, based on your experience, do you have like a preference for RBAC versus permission-based versus attribute-based kind of architecture?
Yeah, I mean, depending on how the application is, or I mean, should the application provide roles to the customer or permissions to the customer? It very much depends on the application. It's probably the product manager's call on what kind of authorization they want to provide to their end users. Yeah, so usually we don't have much control over that. Role-based are easier for the customers to understand as well, but if there is like a large enterprise and they want to handle a lot of things with one application, then permission-based kicks in. So it's usually product manager's call. AppSec teams, we have to handle whatever the product offers. So yeah. Any other questions, guys? Yeah.
For the automated API discovery, what kind of output do you provide? What kind of report, dashboard, or whatever?
Yeah.
What is your communication tool for that?
Sure. So, if your developers are already maintaining a list of APIs through open API spec files or Swagger files, you can import all of that. Or I mean, the best thing is you can put us in your staging environment, and just by monitoring your application traffic, we can discover the APIs from there. I mean, your servers, of course, are responding to all the API calls, right? So we can just monitor the API server traffic and get your APIs from there itself. That's how we do it. All right. Any more questions? Thank you.